Hold on 1 second, okay? Thanks. Pop? Yeah.
All right, we are talking about machines today, and although our machines are not quite as exciting as the Popinator, they are pretty important to mathematics. We're going to talk about function machines. So we've got this machine that we take an input, that oftentimes we call x, we drop it in, and the machine does something to it, and then performs an action, and out comes something else. So the function of this machine is to double the input and then add 3. Mathematically, we write that as 2x plus 3. So if I take a 4 and drop it in, it doubles the 4, 8, then adds 3, 11. Notation for functions. One way you're going to see it written is this. F colon x and then that funny arrow and then 2x plus 3. F is the name of the function, because really we could have a second function machine sitting over here. This one's a round one, and we drop something in here, and it does some stuff, and something else falls out, and we have to give that one a name. We'll call that one G. So we give these functions names, call this one function F, this one function G. Now here's the rest of the notation. The colon, such that. Function F, such that. What do you think this means? X turns into, or X is converted into, or X is mapped onto 2x plus 3. Just telling us the input. Two other ways that you'll see functions written are in what's called Euler's notation, function notation, F parentheses X, and Y equals instead of calling it F. A lot of times with graphing, we go this route. Nice thing about this function notation is it tells us which machine to use, and then it tells us what the input is, right here, the x. So a couple quick examples. We've got this function machine, we're calling it function f, and what it does to each x is it squares x, then multiplies by 2, and then subtracts 3 times the number. So, f parentheses 5, f of 5. That just means use function f and plug in 5. First step is to actually do that. Write this down. Don't rely on your mental computation skills. You're going to make some mistakes. Get this on paper, then start crunching your numbers. We follow the order of operations, and there should be no need for a calculator with this one. 2 times 25 minus 15. So that's 50 minus 15. 50 minus 15 is 35. So f of 5 equals 35. The big mistake that people do here is they say, oh, I'm trying to get f alone, right? And they divide both sides by 5. But that's not at all what we want. We want to be able to see that when we use function f and we plug 5 in, the output is 35. Real quick, pause this video and give part B a try. Find f of negative 4. Okay, so here we go. Let's see if you get the same thing that I do. And parentheses here are pretty darn important. More so in this problem than the previous because we're squaring a negative number. And for you calculator lovers out there, hopefully you know by now what happens when you square a negative in parentheses versus out of parentheses. 2 times 16 plus 12. 2 times 16 is 32. .44. So f of negative 4 is 44. Okay, now I'm going to throw something different at you. No more numbers. This time I'm given f of x. What would f of negative x be? So what is the input here? The input is negative x. So wherever it says x, I'm putting negative x. One thing that might help, before we plug anything out, take the x and make it go away and leave empty parentheses in its place. Now take our input, our negative x, and drop it in each one. Make the substitution. Now here's where we got to be careful. Signs all over the place. I see negatives all over. 5 plus x minus, remember this is minus 1 outside here. We don't combine these negatives together. We got to do the exponent first. Negative x quantity squared is x squared. So we have 5 plus x minus x squared. F of x plus 2. Again, guys, why don't you try this one on your own without me? Then come back and see how you did. Here we are, 5 minus parentheses minus parentheses squared. And what goes in the parentheses? The x plus 2. So we have 5 minus x minus 2, that's this part, minus, now I have to expand. Remember, x plus 2 times x plus 2, x squared plus 4x plus 4. Now we use this negative minus x squared minus 4x minus 4, like terms to combine. 5 minus 2 is 3, minus 4 is negative 1, negative x minus 4x minus 5x minus x squared. So this is what happens when we take function f and plug in x plus 2. So in addition to watching this video, you need to do these 3 problems as a part of your notes. There's a bunch of basic substitutions that I want you to just practice, get good at, and then come to class and we're going to work on some more intense things.